Hello everyone, thanks for joining in. Today we will understand these four topics of BGP. First one is types of messages or packets. Second, BGP neighborship states or we can say finite state mechanism. Third, BGP terminologies, and last one, neighborship. So let's start with the first one, types of messages. So in BGP we have four types of messages: open, keep alive, update, and notification. So as we know that BGP forms neighborship over TCP connection only. So each type of messages will be travel over TCP connection only. So BGP will not transmit any types of packets without forming BGP TCP connection. So here open and keep alive messages are like hello messages we use in EIGRP and OSPF. So as we know that in EIGRP and OSPF, hello message we use to discover neighbor or to maintain neighborship. So in BGP we form neighborship statically, right? It sends the message unicast. So there is no dynamic process. So that's why we don't have multicast address in BGP. And as we know that in OSPF we can configure multiple area ID in one router, and in AIGRP we can configure multiple AS number. But in BGP we can configure only one AS number in one router. So as we know that one AS number here represent one company. So in one company, one router can work only one in one company, right? So that's why we cannot run more than one AS number in one router. So in open message, there are four types of messages flow. First one is version. So by default, version of BGP is 4 that we are using. So it should be same on both the routers to form the neighborship. Second one is router ID, or we can say BGP identifier. So it can be the same on the both routers to form the neighborship. And third type of packets will be AS number of routers. So both the routers will share its own AS number, right? And last one is hold down timer. So in open message, hold down timer is 4 minutes, but BGP consider by default 180 seconds. So BGP send open message only once during the whole process. Okay. Now our second type of message is keep alive. So the timer of keep alive is 60 seconds. So it waits three keep alive messages from its neighbor. If it receives, then it's fine. If does not receives the keep alive message from its neighbor within 180 seconds, so it will declare that BGP neighbor is dead. Now our third type of message is update. So it's responsible for carry route information. So in this update message, three types of packets flow. First one is path attributes, second one is NLRI, and third one is withdrawn or discarded routes. So path attributes is like metric that we use in EIGRP and OSPF. So path attributes are those criteria of BGP that is used to select the best path in their network. Okay. And NLRI full form is network layer reachability information. So actually this is a prefixes. Okay. So we use prefixes in BGP, the term called NLRI. And third one is discarded routes. Suppose any interfaces goes down, then it will generate that this interfaces goes down, and now we will not receive these prefixes from its neighbor. Okay. So these three packets flow inside the update messages. And last one, sorry, last message is notification. So this message will be generated before it's going to break its neighborship. So before breaking the neighborship, it will inform to its neighbor that we are going to break the neighborship. Okay. Now our next topic is BGP neighborship states. So as we know that there are six types of states: idle, connect, active, open sent, open confirm, and last one is established. So this is the diagram. So guys, you can take the picture or a screenshot, and here there are multiple events, and the description of each events is written over here. So we can take the screenshot to explain better. So first one is BGP start, second BGP stop, third one is BGP transport connection open. Transport connection open means BGP TCP connection initiates. And fourth one is BGP transport connection closed. That means BGP connection established or TCP connection established. Fifth one is BGP transport connection open failed. That means failed. TCP connection failed, not established. BGP transport fatal error. There is error in TCP connection. Seventh one is connect retry timer expired. That means TCP connection not established and their timer is expired. So the default timer of connect retry is 60 seconds. Eighth one is hold down timer expired. That is 180 seconds. And keep alive timer expired. That is 180 seconds. Okay, receive open message. It receives the open message. So as we discussed that in open message, four types of packets flow: version, BGP identifier, and on AS and hold down timer. And in and it will receive update message, and 31 is receive notification message. So let's start with the diagram. So here, as we know that when BGP will be configured on one router, so it will be in idle state. Okay, so here we can see that when first event will be occur, that means when BGP will be start, so it will move to connect state. Okay, so from connect state it can move back to idle state when any one of the event like 2, 4, 6, 8 to 30, any one of the event will be occur, so it will be moved back to idle state. Okay, so 2 means BGP stopped by any region, or TCP connection not formed, it closed, so due to that reason it will move back to idle state. So 6 event is BGP transport fatal error. There might be any error that TCP connection not formed. So due to that reason, it will move back to idle state. Suppose our neighborship states reach to connect state. Okay, so it will move back. It will move to active state when event 5 will be occur. So event 5 is BGP transport connection open field. That means TCP connection not formed. So it will move to active state. So suppose our router is in state active state, so it will move back to connected state when event 7 will be occur. So what is the seventh event? Seventh event is our connect retry timer expired. That means 60 seconds timer expired, our TCP connection not formed. Okay, now suppose our router is in connected state, so it will move to open sent state when event 3 will be occur. So event 3 means our TCP connection formed. So it will be in open sent state. Now our router will be moved to open confirm state when event 10 will be occur. So event 10 means it receives the open message from its neighbor. Okay. Now our router will be moved to established state when event 11 will be occur. So 11 means it will receive the keep alive message from its neighbor. So we can see in detail that as I said that Cisco initial reconnect retry timer is 60 seconds. So connect retry timer for each subsequent event is twice the previous time. That means suppose first one any router try to establish the TCP connection. So at that time the our connect retry timer will be 60 seconds. Okay. Now suppose connect retry timer expired, TCP connection not established. So when that router will try to form the TCP connection the next time, then at that time connect retry timer will be 120 seconds. That means twice the previous time. And next time that timer will be 240 seconds. Okay, like that timer will be increases twicely. Okay, so in detail here we can see that BGP always begins in the idle state, so in which it refuses all incoming connection. So when start event 1 occurs, start event 1 means BGP start occur. So the BGP process initializes all BGP resources, starts the connect retry timer, and initializes a TCP connection to the neighbor. So listens for a TCP initialization from the neighbor and changes its state to connect state. So it will move to second state. Okay. Now in the connect state, BGP process is waiting for the TCP connection from its neighbor. So if TCP connection is successful, so BGP process clears the connect retry timer and send an open message to the neighbor. So when it will send the open message, it will move to open sent state. And suppose that TCP connection not established, so it will move to active state. Okay, and it will again retry to form the TCP connection. So once the connect retry timer or hold on timer expired, so it will move back to connect state. Okay, now suppose our router is in open sent state, it has sent the open message to the neighbor. So BGP is waiting to hear an open message from its neighbor. So when an open message is received and all the fields are checked, then it will send a keep alive message. Okay, so in this state, BGP process waits for keep alive message. So after sending the keep alive message, it will reaches into open confirm state. So once the keep alive message is received from its peer, then it will move into the established state. So that was all the states of BGP. So in the interview, anybody can ask when router will be in the idle state in BGP. So we can say straightforward that might be administratively shut down your neighbor, or suppose we are forming the BGP neighborship with the loopback. Okay, and the by default TTL value in BGP is 1, right? So we have to increase the timer in BGP. So might be the reason that your TTL value is 1. Okay, that's why your BGP is in idle state. Now what is the reason that our router is stuck in the active state? So there might be two reasons: that if authentication is not matching, we have configured suppose that MD5 authentication, and at the peer end authentication is not configured. So that might the reason. And second one is that suppose you have enabled the BGP on one router and it's not configured on the peer end router. So that's the reason that BGP is stuck in active state. Okay. Now our third topic is sorry, BGP terminologies. So one more thing, sorry, I forgot that BGP only supports MD5 authentication. It doesn't support plain text. Okay, so that to be keep in mind. Now our next topic is BGP terminologies. So in BGP there are two terminologies. First one is IBGP. That's full form is Interior Border Gateway Protocol. And second one is EBGP, that is Exterior Border Gateway Protocol. Now suppose we have three routers R1, R2, R3, and R1 is in AS100 and R2 is also in AS100 and R3 is in AS200. So as we know that each AS number represents one company, right? So R1, R2 is in the same company that represent AS100, and R3 is in different company that represents AS200. So when R1, R2 will form the neighborship via BGP, that neighborship will be known as IBGP neighborship, that is Interior Border Gateway Protocol neighborship. And when R2 and R3 will form the neighborship, that neighborship will be known as EBGP neighborship. Okay. Now the AD value, or we can say default AD value of IBGP is 200, and the default AD value of EBGP is 20. So what is the reason that IBGP AD value is defined as 200 and the AD value of EBGP is 20? So as we know that these two router in the same company, right? So why we will configure here BGP? So in the previous lectures that we already discussed that if it is not required, BGP protocol is not required, so we will not configure on any node because it requires the high memory and high compatibility, right? So in the same network we can use OSPF, BGP, or RIP protocol. So that's why the AD value of IBGP is 200. So by mistake, if we have configured the BGP in between two routers, so that BGP protocol will not be preferred over IGP. So EIGRP, OSPF, or RIP will be preferred over IBGP protocol. Now, Suppose we are trying to establish the neighborship between two routers and these two routers is present in a different company. Okay. Now by mistake we have configured the EIGRP or OSPF, and we also established the neighborship with BGP. So here eBGP will be preferred over IGP protocol, right? Because here might be there is lacks of routes, and might be this router, if we have run the OSPF or EIGRP, so that much of prefixes this router will not support, or the OSPF protocol will not support. So that's why eBGP will be preferred over IGP, right? And one more thing here, that suppose we have one loop back behind R1, that is 10.10.10.10/32. So this IBGP router will receive this prefix as a interior prefix. Okay, because it is receiving from internal router. And suppose this prefixes reaches to R2, so when R3 will receive these prefixes, so this prefix will be known as exterior prefixes or external prefix. Okay, so here we can see that if we receive any route from IBGP neighbor, or we can say two routers in the same AS, so that is known as internal prefix. If we receive any route from eBGP neighbor, so as we know that R2 R3 is a eBGP neighbor to each other, so two routers are in different AS, that is known as external prefixes. Okay, so here we have written here that if we receive any route from IBGP, the default AD value will be 200. If we receive any routes from eBGP, the default AD value will be 20. So we have already explained why do we have AD value of IBGP is 200 and eBGP is 20. And there are two types of neighborship in BGP, that is direct neighborship and indirect neighborship. So only in BGP we can establish the neighborship indirectly, right? We cannot establish the indirect neighborship in OSPF and EIGRP, because in BGP we'll form the neighborship statically and all the messages will be flow unicastly, or we can say goes hoop by hoop. That's why it's possible to confirm, sorry, to establish the neighborship between R1 and R3 without including R2, right? Now this was the agenda for today, folks. In the next topic, sorry, in the next video we will cover path attributes, and this is a very important topic in BGP, and we'll do the practical part. So till the next video, I'm signing off. Take care.